Hello and welcome to our lesson on the graphs of functions. This is going to be from section 2.2 in our Precalculus text. The one and only definition that we're going to cover in this section is the vertical line test. The vertical line test basically says for a graph to be a function, so we're focusing on a graph being a function. It says that every vertical line that you could possibly draw can intersect the graph only one time. So another way to say this is if a vertical line touches the graph more than one time, it's not a function. And now let's practice. We've got a couple of examples here. Number 13, we want to know, is this a function? So you're simply looking for anywhere that you can draw a vertical line that will touch more than one time. If you can find such a vertical line, then that is not a function. So number 13 would be a no. Number 14, notice that every vertical line that I could possibly draw will touch the graph only one time, and therefore this is the graph of a function. All right, let's run through four more examples. Number 17, if there is a vertical line that touches more than one time, then that graph is not a function. Number 18, again, a vertical line touches more than one time. That is a no, not a function. Number 21, again notice that every vertical line that I could possibly draw will intersect the graph only one time, and that means that that is the graph of a function. And number 22, again, every vertical line that I could possibly draw touches the graph only one time, and that is a function. The next concept we need to look at in this section is, given the graph of a function, how do we interpret and answer questions about that graph? So here we've got a lot of parts to get through. First, part A says to find particular function values. So remember, function notation is f of x. Whatever is in the parentheses is your x value or your x coordinate. Also remember that f of x together means y. So when they're asking us to find f of 0, they're actually asking us when x is 0, what is the y value? Well, we can do that through the coordinates given on the graph. At this ordered pair, we have an x value of 0, which means that the y is 0. So we can say f of 0 is 0. They also ask us to find f of 6, which means I need to go to where x is 6, and the y coordinate is the answer. Again, this is referring to ordered pairs on the graph. Part B, they want us to find f of 2. Same song, second verse. F of 2 says go to where x is 2, and the y coordinate is the output. Also, f of negative 2, where is x negative 2? Here. And so the 1 is the y coordinate, which is the output of this particular function. Part C, it says, is f of 3 positive or negative? Again, remember, f of x is y. Notice that there is no ordered pair given on the graph for 3 comma y, so we're going to have to estimate that. We know that 3 is between 2 and 4. If I go down to where I hit the graph here, simply going down means that that value is going to be negative. Next, part D is f of negative 1, positive or negative. Same song, second verse. We're going to go to where x is negative 1, approximately. Notice in this case, we would have to go up to find the point on the graph. that corresponds to an x-coordinate of -1, and simply the fact that we're going up means that that y value will be positive. Next, part E, for what values of x is f of x 0? So we know f of x is y. Here they're basically asking me for all of the values of x that have a 0 y coordinate, and that would also correspond to the x-intercepts. So those values of x where y is 0 are going to be 6, 4, and 0. And it doesn't really matter what order you write them in. I'm going to write them in increasing order just for fun. Okay, next, part F, for what values of x is f of x less than 0? So here we're looking at the values of x where y is less than 0. We know that on the graph of a function, when y is less than 0, those values have to be below the x-axis, and our graph is below the x-axis from 0 to 4. Every x-coordinate from 0 to 4 will have a negative y-coordinate, which means y would be less than 0. Notice that it does specify specifically less than 0. So using an inequality, we would say that x has to be bigger than 0, but less than 4. Let's make sure that makes sense here. The x's, again, that correspond to our negative y values, have to be between 0 and 4, and 0 and 4 cannot be included because at 0 and 4 it's equal to 0, but our question specifically says strictly less than 0, so this would be our inequality that would satisfy those particular values of x. Next, part G, what is the domain of f? Well, the domain are the values that x can be. And since our graph is continuous, that means there's no break in the graph. X can be anything from -4, because that is where the graph begins, up to and including 6. So that would be the domain of our function, everything from -4 to 6. If I want to write that with inequalities, that would be -4 less than or equal to x. Again, if you read this backwards, this would say x is greater than or equal to -4, but x has to be less than or equal to 6. So that would be your domain written as an inequality. The other way that you could express the domain of this graph with interval notation would be everything from -4 to 6. The brackets indicate that the -4 and 6 are included in the domain. Next, part H, what is the range of f? The range are the values that y can be. So looking at our graph, the lowest that y can ever be is -2, and the highest that y can be is 3. So we're going to say that y has to be greater than or equal to -2, but y has to be less than or equal to 3. So again, as an inequality, -2 greater than or equal to y. Again, backwards, this says y is greater than or equal to -2, but y has to be less than or equal to 3. And that is the range written as an inequality. Next, part I, what are the x-intercepts? Well, that is the same answer as part E, because an x-intercept exists when you have a y value of 0. So the x-intercepts, if I simply just express them as the x-coordinate, would be again 0, 4, and 6. Sometimes they may ask for the x-intercepts as ordered pairs. Make sure that you read the instructions and give the answers the way they request them. Next, part J, what is the y-intercept? Notice it doesn't say y-intercepts. That's because if your graph is a function, you will have only one y-intercept, again because of the vertical line test. And the y-intercept exists when you have an x-coordinate of 0. So if we go back to our graph, looking on the y-axis, we can see that the point on the y-axis that the graph goes through is the origin, 0, 0. So our y-intercept would be y equals 0, or as an ordered pair, 0, 0. Next, part K, how often does the line y equals -1 intersect the graph? We know that if an equation has y and no x, it's horizontal. So this line would be horizontal at -1. So if I go to -1 on my graph and draw a horizontal line, we can see it's going to intersect the graph 2 times. So K, how often does the line y equal -1 intersect the graph? That is twice. Part L, how often does the line x equal 1 intersect the graph? We know that if an equation has x and no y, it's a vertical line. We know that every vertical line will intersect the graph only one time if it's a function. So I don't even have to look at the graph to answer this question. Since I know that the graph is a function, I know that a vertical line, no matter where it is, will intersect the graph only once. Part M, for what values of x does f of x equal 3? Again, this is saying when does y equal 3? So we need to go to the graph. We need to find all of the x coordinates that have a y coordinate of 3. At y equals 3, there is only one ordered pair, and the x coordinate that corresponds to a y value of 3 is 5. So this part has only one answer. That's going to happen when x is 5. And for the last part in this problem, for what value of x does f of x, remember that's y, equals -2. So again, going back to our graph, looking at where y is -2, we can see that that is only going to be at one point, and that is when x is 2. And so this part of the problem has only one answer, x equal 2. And that's going to do it for this section of the lesson. And for the last portion of this lesson, here we're going to be given a function, and we're going to have to determine specific outcomes and answer specific questions about the given function. Part A, is the point 3, 14 on the graph of f? Well, if this ordered pair satisfies the function, that means if I substitute and I get equality, then it will be on the graph of f. So what does this say? This says if x is 3, then y has to be 14. And I hope everybody at this point knows that f of x is y. So over here on the side, we're going to replace f of x with 14. We're going to replace every x with 3. And then we're going to work out and see if we get equality. 14 equals, that's going to be 5 over -3. And those are definitely not equal. So the answer for part A is a definite no. That point is not on the graph because it did not work in the function and give equality. Part B, if x is 4, what is f of x? In other words, it says what point is on the graph of f. So here again, we're going to replace every x with 4, and we're going to calculate the y coordinate. In other words, we're going to be calculating f of 4, 4 plus 2 over 4 minus 6. That's going to give me 6 over -2, which is -3. So the answer to the first part of B, where it says what is f of x, well, f of x is negative 3. That's the first piece of the answer. And then when it says what point is on the graph of f, the point indicates an ordered pair. And that, as an ordered pair, would be x comma y 4, negative 3. Part C says if f of x is 2, remember that is actually saying if y is 2, what is x? So in this case, we're going to be replacing f of x with 2 and solving for x. That's going to give us 2 equals x plus 2 over x minus 6. Multiplying both sides by x minus 6, that's going to eliminate my fraction. And on the left-hand side, we're going to need to distribute, giving me 2x minus 12 equals x plus 2. And then we're going to do a little switcheroo, bringing the x over and the negative 12 back. 2x, that becomes minus x, equals, that becomes 12 plus 2. And we're going to get an x coordinate of 14. So again, for part C, it says what is x? Well, in this case, x is 14. And the point, that means written as an ordered pair, would be 14 comma 2, because the y was 2. And that's going to do it for part C. Part D, what is the domain of f? Well, this is where you have to know something about the type of function we're given. This particular function happens to be a rational function, and we know that a rational function has a restriction, and the restriction of every rational function says that the denominator cannot be 0. So if you're going to find the domain, which means if you're going to find the values that x can be, you need to sometimes look for what x can't be. So in this case, solving for x, we see that x cannot be 6 because plugging in a 6 would make the denominator 0. This is the only value that x cannot be, but if you simply leave this as x cannot be 6, that is not the domain, that's the restriction. To make it the domain, using set notation, we would say the set of all x such that x cannot be 6, and this would be your domain in set notation. Now there is also interval notation. Remember that this set notation basically says x can be anything as long as it's not 6. So in interval notation, we would say that x can be anything from negative infinity up to 6, not including 6, but then everything just a little bit bigger than 6 to infinity. Basically, this says that x can be anything from negative infinity to infinity except 6. And again, this is the domain written in interval notation. Part E, list the x-intercepts, if any, of the graph of f. We know that x-intercepts occur where y is 0. So we're going to need to replace f of x with 0 and solve for x. Here on the right, we now have f of x replaced with 0. In order to solve for x, the first thing I'm going to have to do is get rid of the fraction. And to do that, we're going to need to multiply both sides by the denominator. Okay, so if I show that, the left-hand side is super easy because 0 times anything is just 0. On the right, well, I guess this is super easy too because the denominators cancel, leaving me x plus 2. And then one more step and I'm done here. X equals 2. That would be the x-coordinate of the x-intercept. So if we were to write that as an ordered pair, the x-intercept would be 2, 0, and there is only one of those. And part F, the last piece of the puzzle here, says to list the y-intercept of the graph of f. We know that the y-intercept exists where x is 0. So to calculate the y-intercept of a function, you basically need to calculate f of 0. Replacing every x with 0, f of 0 is going to be 2 over negative 6, which reduces to negative third. And remember, this value is your y. That is the y coordinate of the y-intercept. Written as an ordered pair, 0, comma, negative 1/3. And there is only one y-intercept here. And that's going to do it for this particular lesson. So if you have any questions or comments about anything I've covered, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.